Morning, everyone. It's Dan Sanning from the Institute for Catastrophic Loss Reduction. Thanks very much for joining us this morning. This morning we have John Duong, who's going to be talking about Halton Region's Basement Flood Mitigation Program. John is the Manager of Systems Planning and Customer Service in the Public Works Department at Halton Region. He's got his civil engineering degrees from McMaster, bachelor's and master's, and he's been in the industry for about 16 years. He's also the past president of the Water Environment Association of Ontario, and I understand he was actually at the region when the flooding occurred in 2014, so he'll provide a pretty good perspective for us today. Just to let you know, this will be the last webinar of this year, and we don't quite have our schedule together for next year, but we'll be sending out emails shortly with the schedule for next year, so keep an eye on your inbox. As usual, if you participated in our webinars before, we'll invite online participants to ask questions at any time during the webinar. You can use the question box, which is on the little tool that's on the top right of your screen. If you expand that out, you can find the question box. There's no need to wait until the end of the webinar to ask questions. Ask questions anytime, but we will hold online questions until the end of the webinar. We've got a few people in the room here who might ask questions throughout, if that's okay with John. But for the most part, we'll keep the discussion to the end. And with that, I'll pass it to John.
Okay, thank you, Dan. Thank you, everyone, for joining in for the webinar today. As Dan mentioned, my name is John Duong, Manager of Systems Planning and Customer Service at Halton Region. And just before the presentation, Dan did, I guess, point out that the customer service aspect in my title is a new thing. And of course, for public works and typically municipalities in public works, the customer service aspect of it is a new frontier that we're exploring, and it deals a lot to do with customer service. As you'll see today, the customers here being residences and other industries and commercial businesses within the municipality. So as Dan also indicated today, I'm going to talk to you about our experiences at Halton Region with the flood of August 14, 2014. And we'll get into some of the results, some of the actions that happened after the flood, and get to where we are today. It's been 2 years, just over 2 years, and there's still a lot of work that's been happening, but we've also done a lot of work. It's going to be a tight time frame to try to fit everything in within the time that we have today. So I will be maybe rushing through some things, and if there are things that are being passed by a little too quickly, just let me know, ask those questions, and I'll be glad to answer any of them. So today, what I want to talk to you about is a presentation outline here. Just I'll give you a little bit of a background of what Halton Region is, where we are. I'm going to talk to you about the August 2014 flood, followed by Halton's response, what we did. We'll go into what some of the direction that was given by council, basically to find the causes of what happened during that flood, why people were flooding, looking both from the public side and the private side. So the public and private side is always something that's been a big discussion when we're looking at causes of basement flooding. And a lot of municipalities do basement flooding mitigation work, and it's very normal to have lots of different types of activities trying to prevent and mitigate basement flooding. But they have normally been occurring on the public side, because looking into the private side has always been difficult and challenging from both a legal side as well as a complexity side. I'll get into what our basement flooding mitigation program is today. There's still things that are evolving as we speak. The program aspects, program components of it is still being developed. I'll talk to you about what we did on the public and private side, and then I'll finish it up with some of the lessons learned and what would give you some important things to think about coming from the insurance industry. So, for those who are not familiar, Halton Region is a two-tiered municipality. It's got 4 area or local municipalities and located just west of Peel Region. We have the City of Burlington, Halton, the town of Halton Hills, which encompasses Georgetown and Acton. Also, the town of Oakville and the town of Milton. As the upper tier municipality, Halton Region provides some of the higher and more regional services such as water, wastewater, regional roads, community services, social services, and many more. We are currently at a population of 530,000, and as you can see, in basically 15 years, we're projected to grow by almost 50%. So it's a huge growth, as many of you probably have seen driving by either Oakville or Milton. It's been one of the fastest growing communities in Ontario for a while. So in terms of our sanitary assets, and sanitary I will be using today is the wastewater side. So I will interchangeably use sanitary, sewers, wastewater. They all mean the same thing. Basically, water that comes from your toilets, your wash, your tubs, any of the water that comes from your house that leaves the property is considered wastewater. So at Halton, we have 7 wastewater treatment plants, and these are basically plants that are used to clean the wastewater that comes to it, and then discharges it into the water receivers, whether it be a stream, a creek, or a lake. There's about 85 or so pumping stations. 85 plus is there because there's a lot of developments, and when there are developments, once the developments are completed, they're done and constructed by the developers, but then we take over the pump stations afterwards. So those change all the time as well. We have over 1,900 kilometers of sanitary sewers, over 35,000 manholes, and the sizes range between 150 millimeters to 2.4 meters of diameter of sewers. So they span from small to very large. Our sewer system is defined as a separated system, which means that the storm sewers and sanitary sewers are separated and do not connect to each other. In some municipalities, such as certain areas of Toronto and Hamilton, there are combined sewers. So when it rains, water is directly drained into the same pipes that carry the wastewater. So in Halton, although effects of climate change continues to affect all of us, but basement flooding is not a new phenomenon, and which causes a lot of devastation to homeowners and businesses for decades now. We've experienced basement flooding a while back, and since I've come into the region in I guess 2005, I've taken over, I guess, the group that has to do with basement flooding. But basement flooding is also part and parcel of inflow and infiltration control. So inflow is basically the fast response of rain that gets into our collection system. So basically, for example, there's those holes in the sewer manhole lids. So when it rains, water enters the system really quickly. Or if there are downspouts from the homes that are directly connected into our sewer systems, water enters the system directly. So it basically gets onto the roof, down the spout, and then into our system. So that's what we call inflow. Infiltration is the slower response time of water that has to pass through the ground before it penetrates the pipes and gets into our system through cracks and holes, things like that. So those are slower response type of action. So we've had a team basically, created or developed since the 1990s. We recognized that there were a number of storms that hit in the 1980s that caused basements to flood. And by the 90s, the Halton region recognized that there was a need to put some staff directly committed to trying to deal with the flows that get into our system. However, as I mentioned, we've always only done things on the public side. So where the sewers are laid, where the manholes are, we try to cut down as much of the water that gets into our system as much as possible. We'd look for things that were basically obstructions in the pipes, try to find areas where we can make the flows, be smoother, or construct tanks that basically can store certain amounts of volume during storm events. In 2007 and 2008, several storms hit the same area over a period of a few months. Each of the storm events resulted in a number of homes with basements flooding due to sanitary sewer surcharging. And when I say sanitary sewer surcharging, that's basically when water gets into the system, our pipes, that basically overloads the pipes. The pipes no longer can drain by gravity, and so what happens is water starts to back up the pipe, and as it backs up the pipe, it continues and backs up into other pipes that lead into people's homes and their basements. That's the first point of really the entrance into the homeowner's house is at the basement. So the water backs up and spills over into people's basements whenever our sewers are overloaded and cannot take the amount of wastewater and a combination of water, clean water, at the time when there's a major storm. So the region investigated sewers in those areas and could not find any blockages that could have caused the basements to flood. So the region evaluated the sewers and determined that they were basically overloaded during the storm events, and that the greatest source of stormwater coming into the sanitary sewers is from the private side. So these would be, as I mentioned previously, based on downspouts if they were directly connected, or it could come from foundation drains and weeping tiles. So those are basically pipes that are laid around the outside of homes, around the foundation, and the purpose of those pipes, the weeping tiles, is to take water that penetrates the ground and gets into the ground in your home, in your property, and drains it away from your house. The big advantage of that, obviously, is that you don't have a house that is submerged. There's no forces that basically cause the house to lift up because of the water being surrounding your house, and also it I guess prevents damage to the outsides of your house. So that's basically the main purpose of the weeping tiles. Some of those weeping tiles, if they're connected to the sanitary sewer line, the drain, can also cause a lot of the overloading of our sewers during the big storm events. So recognizing that there's a lot of issues on the private side, the region at that time in 2008 developed a basement flooding subsidy program to reimburse homeowners 50% of the cost to address private side sources. So, as I mentioned, downspout disconnection, so there was a 50% subsidy to disconnect that, 50% subsidy to disconnect weeping tiles and install a sump pump, and then also 50% subsidy to install backwater valves. As typical in, I guess, in all programs, whenever it's recently in your mind or just recently affected you, there's a lot of interest at first. There's people interested in the program, wanting to understand more, not necessarily wanting to fix the issues in their private side because they still have to put up money, they still have to pay for a lot of the work. But there was a lot of interest. However, as time goes by, as what people tend to do, they typically forget about them and their interest weans off, and our program at 50% became a little bit more stagnant, and every now and then it would come up, but there was not a lot of work and activity based on providing the subsidies. So in 2014 came the I guess would be our massive storm that affected the city of Burlington. This, and no pun intended, but was almost a perfect storm in terms of providing drivers and causes or reasons of really initiating our work today and really blowing up what our basement flooding mitigation program is on both the public and the private side. So we had repeat basement flooding. Several neighborhoods experienced a storm event in May of that year, May 2014, that caused some flooding of a few homes. Now, typically we would investigate, and we did again and determined that the sewers were fine. Again, it's just this surge of flows coming into our system that caused the homes to be flooded. But because it happened in May and it happened again in August, there were a number of residences who were up in arms and very upset with obviously dealing it with twice in just a number of months. We also had a new commissioner of public works come in, so new mandate, fresh eyes, fresh ears, a lot of enthusiasm and energy. And then we also had the municipal elections. So as I guess you may all be aware, there's things that they gravitate to and things that they use for being elected again or using as platforms, and this was an ideal campaign election platform. So there was a lot of energy behind the councilors and their needs and drives for their community and their residences. So they were fully supportive and actually got in, I guess, a little too deep sometimes and became like technical engineers at times, telling us what we could and couldn't do. So, but what that created was really the perfect storm for us to really jumpstart our program and get things happening, not just on the public side, but the private side too. So, August 4th, 2014. As you can see in this, I guess, chart map here, it was very isolated. It's a very narrow band that really hits the area in Burlington. I mean, just a few kilometers away, they didn't experience anything in Hamilton, right? But it was a narrow band that passed through different parts of Burlington. So on this map, you can see that the hardest hit was a sliver through parts of Burlington that were in an older area. So the homes will have direct connections, and I'll talk about that shortly. But almost 200 millimeters dropped in or was dropped in an 8-hour period. 60% of that in a 2-hour time frame. So that's really, really, I mean, high in terms of amount of water. I don't know if you can see, but on the bottom right, basically, the average rainfall for all of July and August is typically 160 to 180 millimeters. So in this one 8-hour period, that was more than all of July and August. And then in the pink, I guess, with fuchsia color there, is basically 150 to 200 millimeters of rain in the highest hit areas.
Sorry.
Yep, go ahead, Dan.
Would you hazard guess on the return period in those harder hit areas?
So, in calculating the return period, it was basically a 1 in 200 year storm. So, the frequency return period is really a good indicator to give you people a sense of how big the storm is. It's not that it's the storm happens only once in every 200 years. I guess that's not really the definition of a 1 in 200 year storms, but it's the likelihood of that type of storm, that size of storm, hitting each year is really the 0.005% type thing. So it's a probability of that storm. So it could happen again the following year, but the probability of it happening is just that much lower. So some of the and you may recall in the news or seeing some of the images that happened, but we had obviously a lot of devastation. The picture top middle there, that's the 407 roads were completely shut down. People were canoeing along the sides of their streets. Yeah.
That's sort of interesting that that's the 407, because the 407 is relatively new.
Yep.
And it should have all the new standards, and even under those conditions, it was still fairly severely flooded.
Exactly. So this kind of tells you, even though you may design for storm events, you don't really design for the extreme storm events that could exceed your design limits, right? So if you design for a 1 in 10 year storm, well, 1 in 200 year storm just came and hit, so your system will not be able to accommodate that.
Right. Do you know anything about that picture? Was that a stream crossing there, or?
It is in a lower. There were a number of streams. I'll go back here. I think, as you can see, there's a number of streams and creeks that the storm passed through. The top left figure, the blue lines in the red area. So a number of creeks and streams were all surcharging and overload, and that obviously contributed to some of the impacts and what happened. So in terms of comparing that storm to, I guess, some of the other historical events, and many of you in this industry are obviously aware, Hurricane Hazel in 1954, there was 48 hours of this, I guess, storm. It lasted for a while, and it had basically dropped 280 millimeters. Hurricane Harold, 1989, lasted for just over a day and dropped 450 millimeters. There's a northwestern Ontario storm, 2 days of 400 millimeters. And we also put in here the May event for us that only 5 hours and dropped 23 millimeters, and it still caused some basements to flood. So when you look at that and compare that to intensities, so if you're looking at intensity and you're comparing basically the amount of rainfall that fell in a specific amount of time, people obviously remember Hurricane Hazel, and they remember some of the huge storm events because they were, devastations all across a number of areas. But in terms of intensity, if you look at specifically for the 8-hour duration, Halton Region, we basically exceeded that of Hurricane Hazel and Harold at 25 millimeters per hour. So it was coming down really quickly, really hard, and really fast. The intensity in the 3 worst hours was closer to 50 millimeters per hour to 60 millimeters per hour. So what did we do? Well, when something like that happens, it's basically all hands on deck. I recall that day because I was in Mississauga. I looked in the skies and I saw this huge black cloud, and I figured, oh no. And then I went home and I started getting phone calls from my staff who live in Halton, who were telling me that their basements were starting to flood and all of that, and didn't realize of what really, the impact until the next day when I came in and everybody was basically moving and dropping everything that they were, I guess, their regular activities to help and deal with the flood. We had over 6,000 phone calls that came into the region, and they reported some sort of flooding. So this could be their basements backing up, or water coming in through their windows, water coming in through their doors, just some sort of flooding. So we had 6,000 calls. Over 3,500 of those were related to their own homes being flooded. And we gave out approximately 2,200 ex gratia grants for a total of over $2 million. For those who are not aware, we in the region have a program where we provide ex gratia grants to homeowners who have experienced some sort of sewer backup. It's $1,000, and the purpose of this is really to help owners to offset the premium when they have to get insurance coverage for it. So typically, I guess there's a deduction, or there is a cost, and so that's the region's way of helping out the homeowners when there's a sewer backup. Now, being the big storm that it was, we obviously could not simply just say and determine and confirm 100% that it was a sewer backup in a lot of these homes. So council decided that there is a lot more flexibility at this time, and gave them a little bit more of a leeway in terms of not being as detailed and scrutinizing each and every home for the ex gratia grants. We had to actually hire consultants to come in to help us deal with each of the homeowners. We also had a card where we dealt with a outside company who they called and dealt with their claims and talked about their what happened in their homes, because obviously our regular business and number of people are not built to take in all those calls and talk about their losses and their claims. So we personally, including the consultants, visit over 3,000 homes and gave out these ex gratia grants and try to help the homeowners where we can. A lot of them, unfortunately, as you're all aware, whenever something like this happens, there's always a reactive side to people's nature, try to get things immediately. However, there's a lot of danger that comes with a basement that is flooded, and some of them are flooded completely to their ceilings because they're that low lying, with water that is contaminated with wastewater, and also with electrical outlets that are still kind of lingering in the basement. So we had to help the homeowners and give them some advice in terms of what they can do and what they should do in terms of calling people in. We completed basement flooding mitigation work for a number of homeowners that, again, this happened more than once. So the homeowners in the May event, and this was a direction from council that, there's a number of homes that flooded more than once in a very short period of time. We need to do something to get them out of this situation ASAP. So we had direction from council and senior management to go out and basically retrofit their homes and do work inside their homes to fix the problems. And this included doing the disconnections of the downspout, disconnection of weeping tiles, putting in sump pumps, and putting in backwater valves. So this was at a cost to Halton Region, and we paid for all of that work. We also streamlined the subsidy program, made it a lot simpler for people to start getting access, because obviously, again, now that it's hit them, now there's a lot more interest in terms of trying to get work to prevent future flooding from happening again. There was also an enhanced and increased frequency of waste pickup, so our garbage trucks and came around much more frequent than the typical 1 and 2 weeks that we have. And then we also started to increase our education for basement flooding, obviously with each and every call, but we also created very quickly and quick turnaround with booklets, pamphlets, just information for homeowners what to do. So based on, I guess, all of that happening and the devastation, council immediately gave us the, I guess, direction to go out and try to find what are the causes. Looking at a fulsome review of our own sewer system as well as the private side. So looking at finding the causes and remedies, we retained a consultant company, and they basically use a clean slate approach of looking at everything from scratch, looking at contributions from blockages to capacity limitations or restrictions where there could be efficiencies made, looking at the contributions from the private side, what typically happens. So they came on and they reviewed all of our previous work, and based on some of the work that we did, we moved and had, I guess, a strategy. So moving forward, a strategy for basement flooding. But they also gave us a recommendation to look at our work in terms of phases. So dealing with the immediately, I guess, affected homeowners and residences in Burlington as our first phase, our high priority, and looking at the region as a whole as the second phase. So once we got an idea of how we're going to deal with, finding the causes, using that, leveraging that, finding the solutions, and taking that and leveraging that and using that for region-wide as well. So there were 7 priority areas, and this priority areas we kind of determined and just defined as drainage areas, because in the wastewater, it's really a gravity system, so it all drains to one low lying point, which usually is where a pump station is located. So there were 7 of those areas in the zone that was hit the most in Burlington. We also looked at one other area in Milton that had repeat basement flooding because it extended over there as well. So in the phase 1, we were given recommendation to implement any actions necessary and expeditiously as possible. And then in phase 2, extend the review to region-wide, as I said, using a similar approach to reduce the risk of future basement flooding. So here's the, I guess, the 7 areas. As you can see, they were broken up, and there's obviously a lot of, I guess, scatter when you look at homes that are flooded, some of them in different neighborhoods for different reasons. And we couldn't do everything, but we were able to confine the space or the boundaries to these areas. So what did we find? Through our desktop study, and it was a lot of desktop review, we have a really good sewer inspection program at Halton Region. We do a TV inspection of all of our sewers, so we know what the condition is in. We also have a GIS of our entire network and hydraulic model. So using all of these different tools and sets of information and data, we basically found that the sewers were generally in good condition. The sewers were designed the way that they were intended to be used. There were no big gaping holes. There were no big, obstructions, because that's one of the things that we want to make sure, that there is nothing on the public side that added to any of the homes that had basement flooding. So there were some opportunities to enhance or optimize the system. So pipes are not free of defects, meaning there are going to be some cracks, there are going to be some deformations or things like that within the pipes and the manholes. So based on the review, there are some opportunities where we can make those areas tighter. Now, when I say tighter, the design of sewers actually accommodates some water to get in. In the design of sewers, there's a recognition that there's no way that you can keep all water outside of the pipe. So there's a factor that is used. So, however, when we're talking about what we're doing here, we're going beyond the levels of typical service here, because we're starting to seal or identify projects that optimizes the sewers to a point where we're trying to not have any water come in. So this is getting into an area where it exceeds industry standards. So what we did conclude from the initial review is that the sewer surcharging is caused by too much extraneous storm water getting into the wastewater collection system, mainly from the I&I. Now, this is, as I started the presentation, is something that we always had suspected. We in the industry know that there's a lot of water that comes in from the inflow that causes the basement flooding. But this study provided the support, the background, and looked at everything as a whole, and now can get into some of the private works. So it eliminates sources of I&I. Basically, you need to try to reduce the water that gets in there. We talked about, or I talked about, the sealing of the public side, but on the private side, the subsidies that were provided, 50%, was not being effective. It didn't get enough attraction. It didn't get enough activity. So the report indicated, okay, we need to do something on the private side. So what the recommendation came out from the phase 1 is basically you need to go out, you optimize the public side sewers, and there was a basically $3.2 million worth of works immediately identified to seal up our system where we can, and either to use a liner or to dig it up and put new pipes in there. But it also looked at downspout disconnection project. So the downspouts is the biggest bang for the buck in terms of trying to prevent the sewers from surcharging right at the start of a storm. In this map here, basically, is the result of one of our first projects of disconnecting downspouts. Because we were given the direction to go and get something done and get it done immediately and quickly, we were given a project or an assignment to have a consultant come in and go out to the homes in the high priority areas, knock on their doors, and ask them if they want to disconnect the downspouts. We would do it completely at all of our costs, so no cost to the homeowners, and we actually had the consultants carry a contractor who did the work. So it was trying to make it as easy and simple and at no cost to homeowners as much as possible. The shading here you see in this map is just one of those, maps created from our consultants to show all the areas that we went into, some of the homeowners were home. We were able to talk to them, and we were able to get work done right away. Some homeowners were not home. We had to do follow-up. Some homeowners who were not home, we followed up. They didn't want to participate in the program no matter what. So we still had people who did not want to be part of the program. But we also started to see that there's a lot of, I guess, complexities, even on downspout disconnections. And downspout disconnections is fairly simple, that you don't need a building code, you don't need a permit, it's not a building code. You can go to your regular Home Depot, buy an extension pipe, and just go over land. But what we were finding is that there's a lot of homeowners who do, I guess, renovations to their home. They change their grading, they do lots of different things on their home that would make, I guess, the disconnection a lot more difficult. So there may be concrete paths right next to where the downspout is going into the ground. And so that basically would cause a lot of issues in terms of disconnecting the downspout and extending it over your lawn. So in those areas, we said we're going to hold off and we're not going to do it because that's not the intent of this program. We're not there to renovate people's homes and do home renovations for them. We're just there to, disconnect the downspouts. So these are a few more maps just showing the participation in the affected areas.
Yes, sorry, can I just ask a couple questions on, so we have waiver refused, waiver under review. That's a waiver saying that they're allowing you to disconnect, and they signed a waiver saying that it's not your responsibility. Is that basically?
That's right. So with each home, we would need to get the homeowner's participation and buy-in and sign a waiver. They would have to obviously sign the waiver, and we typically have this for any of our programs that even when we provide the subsidies for. It's basically just acknowledging that we're there to give you the money, but we don't take any responsibilities, obviously, for the work that gets done. Now, the new waiver, new work, we had to further enhance because now we are doing the work. Now it is our consultants who are going into people's properties and making the disconnections. So there was a waiver that was further enhanced and reviewed and went through all the nuts and bolts with our legal staff, and they did sign that. So for work to be done, they would have to have signed a waiver for us, and we kept that on record. Yeah.
Okay. So and there's a lot of homes that they consult. Do you have an estimate of the number of homes they tried to get to, the number that they actually were able to talk to?
So the number of homes they actually got to were approximately 9,300 in this area. There's a lot of, I guess, properties that are either condominium corporations that we didn't get into because they're private. We didn't get into businesses. So we were accessing basically residential homes. Could be a semi, could be a detached, but they were homes. A lot of the homes also had some of the works already done. So we would acknowledge that the work is done, but we didn't do any work with it.
And out of those 9,300, how many did you identify that needed to have the disconnect done? How many should have it done but couldn't because it was too difficult? And how many actually did do it? So
I won't get into a couple of those questions, but at the end of the day, the result is approximately 1,000 homes that actually got disconnected, and almost 1,500 to 1,800 downspouts disconnected. So we counted the downspouts and the number of homes. Based on the 1,000 homes that were actually done, I think we were only in the area of, I think it was about 3,300 that could be done, right? So meaning it could be done, meaning they had gone back to us and the homes were candidates to get work done.
What would make something not a candidate, just out of curiosity? Like what would prevent the house from being eligible?
So The downspouts that go into the ground, they're usually right along the side of your house, and it goes into like a cap. So if there's a concrete path right next to it,
Yeah.
the only way we would do it as a simple work is to cut it at the ground and extend it along the path, over the path.
Right.
That causes a tripping hazard.
Yeah.
And so we didn't want to introduce some other hazard just by disconnecting one downspout. So for those homes, we said, you know what, we're not going to do that because one, financially, we didn't have the budget to do that type of work, and two is we were going to start getting into a lot of other issues around the homes, because you dig up one thing, it starts to have a domino effect on other things that you might have to do. So things like that we stayed clear from. Okay.
Neighbor's house.
Yeah.
Problem
I was just thinking the downspout going over to like a ground that could absorb the water.
Yes, that's right. So it needed to go into an area that can absorb it, and it be extended 5 to 6 feet away from the home. That's the typical distance that we want.
Yeah.
So side downspouts, you know, if you're that close to your neighbor, we're not going to create a flooding hazard for your neighbor. So we couldn't do those homes. Yeah, I think it's going. I have to point it. Okay. So in phase 2, it's basically taking what we learned from phase 1 and making it region-wide. There is a sewer system optimization capital program. So doing the desktop study, using what we have in terms of our database, and trying to create or identify projects to seal our system as much as possible for the entire region. There was an enhanced basement flooding prevention subsidy program. So now moving away from just the 50% that was not getting a lot of attraction, we were given the authority to make our program 100% for some aspect of it, for most of it actually. And I'll get into that a little bit later. We also identified one of the, taking the lessons learned from the first project of going around disconnecting downspouts. There needs to be a little bit of encouragement to homeowners. Just because you have a program out there, the uptake isn't going to be, as much as you think it is. People will still shy away from getting work done unless somebody is there to guide them along the way, tell them that there's no cost to them, no financial cost to them, and for us to go and do it for them. So we have a targeted downspout disconnection component. So where we go into different municipalities that have, where we've identified there could be a greater chance of connections, that we would target those areas to disconnect downspouts. We also recognize through a lot of work right after the flood that contractors and getting the right contractors was a big problem for homeowners. They, especially in some areas that are older, the homeowners are the elderly. They are not, technology savvy. They don't know what's, what and which contractors to use. There's a lot of, I guess, dirty people out there who are trying and who do take advantage of, people, homeowners, for work that they are needing to be worked on, or they're doing work at huge amounts of cost. And so the weeping tiles is one of those areas where we want that to get done and done properly. So we were seeing that homeowners always were asking, who do you suggest, who do you recommend? And as a region, based on a transparency and our purchasing bylaw, we could not recommend anybody. But what we decided is that we can create an authorized contractors list. So going through a review process where we would look at the contractors, make sure that they have the experience and all the background, and they've had the people, we can put them on this list so that homeowners can go ahead and pick from them, do their own work. Now, although we're creating this list, we've always said to the homeowners, and this is a new program, so we're continuing to try to educate and communicate this, is that it's still a contract between the homeowner and the contractor. The region is just simply giving you a list that you can start with. We're giving you the money to go and do the work. But any issues, any work, anything that's, decided between you and the contractor, that's the agreement. The region we're hands off on that area. We also introduced a new lateral lining and repair subsidy. So this is a new area for us in that basically a lot of homeowners are getting a lot of issues with their laterals. Tree roots getting in, there's things that block their laterals, creating more havoc and basements to be flooded from backing up. So taking that one extra step, the idea is to give them some subsidy, some money to retrofit or fix the pipe on their side. So on the private side, give them a subsidy to either line it or to repair it. Now, lining is obviously a lot cheaper and simpler, but you can also repair, or you have to dig up the pipe, which is a lot more costly and expensive. So we've introduced a new subsidy for that. We also were given the recommendation to have a permanent flow monitoring program. We, similar to other municipalities, do a lot of flow monitoring based on case-by-case basis. So one project at a time, you put flow monitors in there and you assess how much flows are coming in. So the recommendation was to put a permanent flow monitoring program. We also was recommendation from our consultant to have interjurisdictional working groups. So between the Halton region and the 4 area municipalities, as well as the conservation areas, we should be working together, because I know that they have their number of projects to have basement flooding mitigation or basement prevention type of programs. They're more concerned with overland flooding, their streams, their major streams, and with their storm systems. But there are obviously coordination efforts that could be had there. And then there's also the education outreach to enhance and start promoting more of our work, promoting more of what the homeowner can do. So talking about some of the program here, the sewer system optimization is basically a 10-year program identifying approximately $6 million a year just to go out and deal with the sewers that have some minor infiltration coming into it. So that's pretty advanced and beyond, like I said before, the standard of the industry. It's over 10 years. It basically has been identified desktop by consultants, but each and every year we go back and we validate, we look at those projects, and we do coordination and alignment with our own projects as well as the other capital work that happens. So getting a little bit more detail with our Enhanced Basement Flooding Prevention Subsidy Program, there's 2, I guess, amounts in terms of the subsidy. One is a 50% and one is 100%. The 50% is provided to the backwater valve and the lateral lining and repair. So the backwater valve, we have not changed the amount and the subsidy percentage for this. It's $675 per house, so it's 50%. So backwater valves we've found to be in around, I guess the area of $1,200, $1,300, $1,500 to install it. So 50% is approximately $675. This was determined way back. It needs to be building code approved. It must show that weeping tiles are disconnected. So this is an important area here. I guess I just want to get into is that the backwater valve we basically determined that it is a device that is helping the homeowners not have water to get in. But as a region, our main goal is not to have water to get into the system, as opposed to providing the homeowners with the mechanisms of just protecting their basements. So that's why we didn't increase the subsidy for this this component. The backwater valve is good, but if you don't have a surcharging system, the backwater valve won't be needed. So that's where we focus more of our attention to get water out of our system. The other thing is that the backwater valves have been generally put in properly, but what we found in a lot of homes when we were doing the retrofits and installing them is that we found that the connection points of the weeping tiles was actually further upstream from where the backwater valve was installed, causing a really, I guess, problematic situation. If you install a backwater valve and you don't disconnect the weeping tiles, if there is ever a situation where your water is trying to come back into your house, the backwater valve is basically activated and prevents that from happening. So there's basically a block at the valve. But if water is continuing to be drained from your property, surrounding your property, and comes into your drain, the water is going to start flowing up into your basement itself. So it's creating another problem where if you don't disconnect your weeping tiles, you're basically having a situation where you're most likely going to have another basement flooded during a situation or environment that there's a large storm.
That's to the sanitary then, right?
That's to the sanitary.
Yeah, so your weeping tiles to the sanitary.
So in I guess the homes that we've identified are the homes that have their downspouts or weeping tiles connected to the sanitary. And because they're connected there, we need to have that disconnection point, otherwise they will create more problems than solutions.
Sorry, yeah, and so just to reaffirm that point, because I know that's something you wanted to make to this audience, that the backwater valve is effective only if installed properly with foundation drain disconnects. And the foundation drain disconnection both benefits the municipality and the neighborhood because you reduce that water that goes into the sewer system. And if you put a backwater valve in without disconnecting your foundation drainage, you might be creating a new flood problem in your home, because when the valve closes, the foundation drainage water can come into your house.
That's right.
So that's why you have those two components together.
So yeah, so that's why we say in our subsidy that we will give you the backwater valve subsidy, but you must show that your weeping tiles are disconnected. I know dealing with a lot of homeowners after the flood and dealing with a lot of the homeowners who talk about insurance and insurance requests or requirements that they have a backwater valve installed. Now we've had to deal with some of the homeowners and let them know that we can't give you a subsidy on that backwater valve unless you show us that the weeping tiles are also disconnected. But I'm not sure which of the insurance companies make a requirement, but we've heard from a lot of homeowners that they're making them put in backwater valves without ensuring that the weeping tiles are disconnected. Otherwise, they won't get their insurance coverage.
They don't know. It's a technical problem. We're trying to communicate as much as we can, but they don't know. They don't understand. And too many of them think the backwater valve is a silver bullet and will solve all the problem.
Yeah, exactly. The lateral repair is a subsidy that we're providing up to $2,000 per home. It's quite a significant amount in terms of dollar amount, but that's basically 50% of what it costs to line a home's lateral. So you can see the picture there is basically putting a sleeve or sock inside an existing lateral that may be compromised, and so by putting that sleeve on the inside of the pipe, that creates a new pipe for the homeowner. And what we require there is obviously the pre and post, pre and post videos of the lateral to make sure that it was done and that it was needed. The other two components of the program is 100% provided in terms of subsidy. the downspout disconnection, which is up to $500 per house, and the weeping towel, which is up to $5,000 per house. So, although it did mention about the target downspout going into specific areas, anybody in the region, if they want to disconnect their downspouts, we would provide the subsidy too, not just in areas that are more, I guess, higher priority, or they have what we deem as directly connected to the sanitary sewer system. The weeping towels, as I mentioned, we have a new contractors list. The costs will be paid by the homeowner, and then it's one of those subsidies where they do the front end costs, the work, submit an application, and then we will reimburse them for the amounts eligible.
Any ballpark of what the average cost of that is?
Of the weeping towel disconnection, we've basically thought it's 5,000 or so in a standard one, in a typical. Just so the work that you actually do in a standard one is basically you go to the part of your basement. It should be unfinished, right? So looking at an unfinished basement where you just break open the concrete, you find the pipe that is from your weeping towel to your floor drain, because that's where we find them typically. You cut that pipe, you put in a sump pit, and you put in a sump pump. And then you take the discharge of the sump pump through your basement walls, through and to the backyard or somewhere that you can discharge appropriately. So that type of work is $5,000 or so. Obviously, there's going to be lots of different variations because people's finishings of their basements, where things are located, how easy it is to get around walls. So we can't account for that, but we're just making sure that the standard typical basement we can provide for.
Yeah, but $5,000 is a very, very generous subsidy from the municipality for this. It's one of the highest I've seen.
And providing that 100%, getting what, so our council obviously want to encourage as much as possible, put it out there so that it is something that people are gravitating to. They want to do it. And again, you talked about the weeping towel contractors. We do a screening. We review their criteria based on experience with the work, the type of work, that they're licensed, that they have a history. We also, at the advisement of our legal, we've put in a process to suspend or remove a contractor. So making sure that we have the contractors who are good and stay, on the positive side. And with the application, we've also included a customer service survey. So as part of the subsidy, for you to get the money back, we want to hear back from the homeowners. How did the contractors do? How did they hear about it? Some of their feedback, their satisfaction. So we're trying to encompass or incorporate some of the customer service into our subsidy program so that we can obviously continue to improve on it where we can. Flow monitoring, as I talked about before, we have a number of flow monitors already. That's the black, but we're going to continue to increase our monitors in the system with the red and green. Now, flow monitors are very important in terms of trying to quantify and understand what the benefits are based on the disconnections or in the capital works. So if there's a lot of disconnection, you want to measure the flows that are getting into the system before and after. So the flow monitors have been installed and continue to be installed. One of the most difficult things is, though, however, with flow monitoring is that you never get two storms alike. So they're always different. They hit different areas. They have different intensities. They last for a different amount of time, and they travel differently. So it's very difficult to say that you're comparing apples to apples, but if we're comparing similar numbers or similar storms, that's better than nothing. Then with our basement flooding mitigation, the interjurisdictional working group, we've met a number of times already with our local municipalities and the conservation authorities. We've started to share information. We have some work that the City of Burlington, Town of Oakville have already initiated, and we're continuing to partner with them. For example, Town of Oakville with their master plan review, we're helping them. We're inputting into some of the areas that we have determined as higher flooding risk based on direct connections. And then with also conservation in Halton, where they've had a project to enhance their rain gauge network, so we're helping them with that. So it's bringing all the members at the same time. In terms of our education and outreach, as I mentioned, we've created a guide to flood prevention and recovery, and that's not just to do with what you should do to prevent basement flooding, but it's also, as I mentioned before, about some of the precautionary methods if you have a flooded basement, what you should not do. Contact these people. Don't get in there. Make sure that you have gloves on or boots on. Don't get yourself in danger trying to get into areas that you should not be. What we want to do is obviously maximize our voluntary program, and we're going to create our own outreach, going out to falls, fairs, doing different events, going out, communicating with the community. We do have obviously the homes, as we've confirmed, where there's more susceptible basement flooding are those areas that have older residences and they don't have access to internet, so we have to go out there. We'll go and do community outreach. And so in terms of lessons learned, we feel confident that the work that we've done will mitigate basement flooding. So we have made our system better. We've gone out there and reduced the amount of water that's going to get into the system, and for some smaller storms, we probably will be preventing some basements from being flooded. However, we're definitely communicating to everyone and everybody out there, politicians, residences, that although what we're doing, they're not going to be guaranteed that their basement is never going to be flooded again. There's always a chance, a bigger storm, some odd thing that could happen, their basements could flood. It's difficult to differentiate between clean water and, I guess, the sewer water when it comes up. So when there is a flood like the one in August, a lot of the water comes through the sides of the house, through the walls, through the windowsills that we found that basically is going directly there. So when that happens, it's very difficult to know whether it's sewer or if it's just clean water. The sanitary sewers are designed to allow some rainwater, but not direct disconnections. As I mentioned, they are designed to accommodate some. But even though our system is designed for the future flows are just on average day flows. So what you typically use in a day, when a storm comes, that completely surpasses the amount that you use in a day. Sanitary sewer systems have been designed properly and convey wastewater as intended, as I mentioned. And the most effective way to mitigate basement flooding is this, sanitary sewer backup is to avoid overloading the sewer system. So this is disconnecting the downspouts, disconnecting the direct connections. Getting the water out of the systems is definitely going to be the biggest bang for the buck. The downspouts are the quickest way in which water gets into the system. So if they're connected, so we can let it run across the ground to have the natural infiltration to the ground, you're going to have time on your hand. It helps because water can be taken away backwater valves, as we had discussed, is not the solution to preventing basement flooding by itself. Backwater valves, if is a requirement to be installed, must and should be having a caveat that the weeping tiles are disconnected, or some way to confirm that there is no connection upstream of the backwater valve. And controlling the source is the most economical and effective. We had constructed a big tank a number of years back to address some of the basement flooding in homes in a certain area, and that tank obviously was designed for a certain volume, and it cost the region X amount of dollars. I think it's over $10 million at that time, but that tank can only accommodate so much volume of flow. So if the next storm that exceeds the volume of flow, you're going to get your basements flooded again. So, creating big storage systems is not the solution. It helps, but it's not the solution. Is not the effective way. Hitting the source, getting to the source, which is at homes and direct connection, is incentivizing, encourages, but does not see wholesale changes. We've seen that. So that's why we're going out there. We're trying to do more promotion. Face-to-face contact was hugely effective in terms of our downspout disconnection. Getting people to just listen is much more effective face-to-face than trying to talk to them or giving them, programs of flyers and booklets. A lot of people just, put those to the side. And obviously, education is key. A lot of the homeowners do not know how water or anything about the drainage happens in their home. So we're trying to go up there. We're trying to give them information, giving them a little bit more of information of your storm system versus your sanitary system. They're different. They're not the same thing. But if you do things in terms wrong, it's going to impact the other one potentially. And so education is key. And that brings me to the end of my talk.
Okay, great. Thanks, John. We actually have quite a few questions from our online attendees. We've got about 50 people online. Actually, quite a few technical questions from our municipal participants. So, one interesting thing I think we can sort of take away from this is the fact that in your case, in Halton Region, you found that the public side was not the issue. It wasn't failing sanitary sewers or sewer systems that caused the problem. Most of the problem occurred on the private property side, and this is sort of where you emphasized the work going forward, and I think that's sort of an important takeaway for a lot of people. And one question that came up online here, and it's something that I think a lot of people think about. So what I think some people online may not know is that in municipalities where you have an upper tier and lower tier municipalities, like in Halton Region, there's a few of those around Ontario and in other parts of Canada, you have sort of a division of responsibilities for stormwater and wastewater. So you're with the region of Halton, the upper tier municipality, you're responsible for wastewater. And in your jurisdiction, the local municipalities, Burlington, Halton Hills, Oakville, they're responsible for stormwater. So is that's correct? That
is 100% correct. Some municipalities do it differently, but for Halton, we own all of the water and wastewater mains up to property line. So we own even parts of the lateral up to property line, and we take care and are responsible for that. Everything on the private side from the property line to the house is the responsibility of the homeowner, including the water service as well as the lateral of the home. Now, the locals do take care of all the storm sewers, so they are responsible for the storms, and that goes up to property line as well. The locals in our municipality are also the ones responsible for building permits and anything that's to do with construction within that property line. When you need to get a permit to do plumbing, permit to do any type of renovations, permit to excavate and put in a sump pump. So they're the ones that deal with getting the permits and reviewing and inspectors and making sure that it is in conformance with the building code. So that's part and parcel of the work that we do with the interjurisdictional. So the benefits of that is coordinating some of the requirements. So we've made it less of a burden on homeowners in terms of the downspout disconnection and the weeping tile work, where they have gotten their own council to endorse or approve the waiving of permit fees for those type of works. So that is with the local municipalities.
Right. So there's a lot of coordination going on there. And one specific question we had was, did you work with the local municipalities to sort of understand how the stormwater system sort of interacted with the wastewater system to cause issues? So an example might be, if for overland flow routes, running over leaky manhole covers, is that an issue you looked at, and how did you address it?
So the City of Burlington was the municipality that we directly worked with quite a bit in the work that came after August 2014, and they initiated their own studies, and they did a vulnerability study, which is to look at different areas that are like bold areas. So areas where water would run and pond and create a ponding effect. And so we did work with them to ensure that wherever we were disconnecting was not in those ponding areas. So we didn't want to create problems of ponding in those type of areas. And so we know from the City of Burlington, we're also working with the town of Oakville now in our next area of targeted downspout. So we are actively getting their input and feedback.
Great. Another question. So somebody was asking for a little more clarification on what's meant by separated and combined systems. So the question specifically, if I can paraphrase, if there's stormwater getting into the sanitary system and stormwater is backing up into homes, doesn't that mean the systems are connected? So can you sort of clarify what is meant by separated and combined systems?
So a separated system is one in which you have storm pipes and storm systems that carry the water that gets that enters there from storms. So any type of rainfall event, it gets into that pipe and that system, and it is taken to major receivers or creeks, and there is no direct piping from that storm into the sanitary system, in which the system takes away the dirty water from people's homes and businesses. Now, in a combined system, those two pipes, the storm actually comes into the same pipe that a sanitary system is. So it's one pipe that carries both of those waters, the storm water and the wastewater. And in those systems, typically those pipes are much larger, like City of Toronto, but they do get surcharged quite a bit, and they have different types of systems to, remedy the situation whenever there's a big storm. So they have, different storm tanks and storm scepters, and it's those are the combined systems.
Right. And so I guess sort of related to that question is the whole concept. So when you have a separated system, you have a system that is really only designed for wastewater from your home, from toilets and that sort of thing, and then a storm system that's designed to collect water from the street. And they're sort of, under ideal circumstances, completely separated systems, and they convey two different kinds of water. But in your municipality, as in I think most municipalities in Canada, it used to be common practice to take sources of stormwater like downspouts and groundwater like foundation drains and connect them directly into a sanitary system that really is not meant to convey that much water. So why did we do that, and what was the thinking behind that sort of approach, 30, 40, 50 years ago? And then when did it change?
So it changed with the building code. The Ontario Building Code was initiated in 1971, I believe. And that was when it was no longer permissible to connect your foundation drain and your downspouts into the sanitary line. So before that time, it was common construction practice, and that was how homes were built. You take the pipe from your downspouts and you extend it below the ground, and you connect it into your one drain pipe leaving the house. Same with the foundation drain. You take that pipe, you connect it into the one common pipe, and so you have one pipe leaving the house that carries both your rainwater and your wastewater from the home out. With the building code enactment in 1971, that was no longer allowed, so they had to put another pipe, a storm system pipe, and then which meant that there's storm sewers now on the streets. So with storm sewers on the streets, you have another pipe that will take away the clean water from storms. Now, obviously, things don't happen just because the building code gets, printed. So in our evaluation and our assessments, we took a date that is a little bit later than 1971 as what we would think that homes are connected. So we used, I guess, a date of 1975. So we obviously accounted for, a small transition period, let's say, before homes started to be completely disconnected at the source.
Okay, thanks. Another question, technical question, I guess, from a municipal participant here. What was your methodology for identification of sanitary manholes to seal?
So for manholes themselves, we actually have a manhole rehab program. So we do go and inspect manholes annually, every year, and we look at the condition. There is a scoring on that, and we will either fix the ones that need to be fixed immediately, or we'll line, or we'll do some sort of repair on them if they just need to be repaired. Because manholes, there's so many of them, and you do have to coordinate with other capital works, because sometimes it's not worth it to just replace the manhole by itself if the system is all deteriorating and you have capital works coming up soon. So you align it so that you do it all together at once.
Right. Okay. Another question here from a municipality. So if a homeowner does have a failed sewer lateral due to tree roots, before the repair, would you require them to remove the tree, or would the city tree be removed that causes root blockage?
So the city tree, that is within the local municipality's jurisdiction, and no, we do not require the tree to be removed. If there are tree roots penetrating it, we would we would allow them to, I guess, get money for lining of the pipe, lining of their lateral, but there is no requirement to remove the tree. Right,
and so I assume, I guess, once the lateral is lined and it's sealed up, the chances of a tree root getting in are,
that's right,
are much lower.
Yeah, it's construction material of the past days as well that allow some of the tree roots to get in easier than not. So right. with the new lining and new pipe material, it's a little bit more difficult.
Yeah, so you don't necessarily have to lose your tree.
And a lot of people don't like their trees to be gone.
Yeah. Is there any move to use bylaw to make disconnection, downspout disconnection mandatory, banning reverse slope driveways in new construction, anything of that nature?
So the actual enforcement of bylaws is a method that has, reared its head in Ontario. Some municipalities have used it. At Halton, it's really based on the political environment. It is based on, what can you do? Is it the best way? Because with the banning, it's not just simply you have to do it or I'll fine you, but then you start getting into, okay, how do you enforce it? How do you require them to do it? like we talked about the downspout disconnection, if it's a tripping hazard that you're causing, is that what you want to do, right? So there's a lot of other administrative and other factors that will come into play. I know the City of Toronto has their program of how they're doing it, but I'm not sure if they have their full enforcement process outlined and detailed to deal with all of those situations yet. It's a good tool. It's a good thing that you can have when you talk to people so that you can get them to buy in. But for the rest of the population that don't want to do it, there's problems with trying to get them to go all the way and do the work.
Another question about the private side aspect of the program. So your program is relying heavily on getting private side sort of buy-in in doing these measures. How many or what proportion of homeowners need to participate in order to have measurable make a measurable difference? I know you're monitoring with your flow monitors, but you get a sense like, do you need to get 50% of eligible homeowners to participate in downspout disconnects before you make a big impact?
I guess you have to define what is a big impact, but what we've done so far with just 1,000 homes that we disconnected, based on our hydraulic model, it's been a huge impact. There's been decreases, or what we would say is modeled decreases, that are very positive for our system. We've had, obviously, similar to other municipalities, had to deal with development, and development we had put on hold because there were no basement flooding issues, but now we're about to, look at that and consider releasing it. But what we had talked about, and it's more in the report, but you're talking about huge amounts of flow. It's one downspout if you're looking at that. But it's not a direct one-to-one relationship, right? So just because you cut off the one downspout, which may be 1 liter per second, doesn't mean that you're saving 1 liter per second from coming into the system. There's always going to be migration and water getting in other ways. You put it into the ground, it's going to get in there maybe much slower, and parts of it, percentages of it get removed. But what we were estimating, if we did everything here, we were talking about like huge amounts of swimming pool size reductions.
Right. A related question, I guess. So one of the things that we talked about with stormwater, we mentioned it briefly earlier, I think, is the concept of return period. What return period rainfall event can your stormwater system manage? That sort of concept is not typically applied to wastewater systems.
Yeah, no. The design of sewers and wastewater mains does not factor into that any of the storm events. So it takes into account your land, your area, and the flows that are being generated from each lot. So as I say, it doesn't account at all, and it's different for storm systems. So storm systems, and when you're looking at return frequencies, it factors into the storm design, storm sewer design, but not the sanitary sewer designs.
Yeah, and so we wouldn't be able to say for the sanitary side, previously the system was able to accommodate a 25-year return period event, but with the upgrades that you're going to be making or the homeowner participation, it can now handle a 50-year return period event. That's not an analysis.
It's something that's a little bit more challenging and difficult. We are trying to get into that area and make, I guess, assumptions. With our hydraulic model, we're trying to get that analysis done. And what we've gotten so far is basically pump stations have been typically able to associate with return periods, and they are designed to 10-year storms. So we are doing our model and our assessments so that we match that 10-year storm. And so using the model, you basically input a type of storm into the model and see how much flow comes into it. And so that is how we are trying to align or associate the storm frequency with our level of service and the pipes,
right,
and not having basements flood.
Right. Okay. So we're coming up on 11:30 here, which is supposed to be the end time. So just one more question, and I think we'll have to close it down. So in some discussions with the City of Burlington in the past, and we talked about how the local municipality is responsible for storm, and you guys are for wastewater. We've heard of cases where storm sewers are also backing up into foundation drainage and causing flooding. Is there any sense, I know because you said it's difficult to separate what type of flooding caused, or what source of flooding caused flooding in homes, but would you hazard a guess at the proportion of flooding that occurred to those homeowners who complained that was caused by overland versus seepage in the basement versus wastewater sewer backup versus storm sewer backup? Could you give any indication, or is it too difficult?
It's very difficult, especially like looking at the numbers that we were provided and what the assessments that we, I guess, kind of undertook with the August storm. But saying that it's difficult, but we did see people on the ground and our field staff going out there and saying, yeah, we can see like water coming through the walls or coming from the windowsills. We know that it's happening, but in terms of getting in numbers is very difficult. And especially with trying to break up the number of homes that we provide ex gratia grants for, right? The 2,200, it's very difficult trying to separate that and say, well, this percentage of homes came from sewer backup,
right,
and then this number of percentage came from overland flooding. Because once it starts coming in, it's just mixed,
right.
Right. So if you can picture just your sewers backing up and water's coming up from the drain, but because of that storm intensity was so huge, water's coming from the side. So they start mixing, and how do you know which one is first or which one is truly only the water from the runoff?
Right. Okay. So one last question, and it's something that came up a couple of times, was so what can private industry do to help increase homeowner engagement in your region? Private could be insurance, it could be contractors, that sort of thing. What help could you guys use?
I think the biggest help would be to have the backwater valve issue further communicated to homeowners, and having the insurance industry not having that as a requirement, just a straight requirement of you need to put a backwater valve or else you won't get insured. There needs to be the additional follow-up with, well, put the backwater valve, but you need to make sure that your weeping tiles are disconnected, right? So having that message there, and having homeowners know that part of it will help the region, because they're coming to us and saying, we need to do this, but we can't give you the subsidy. You can put it in, but you're going to cause potential flooding of your own home within your own house. So I think that's probably the biggest takeaway, if we could.
Right, and to remind them that there's $5,000 on the table to help out.
Yeah, there's a lot of money in our municipality to help them out.
Right. Okay, well, I think we'll have to wrap it up there. Do you have anything else you'd like to say in conclusion?
No, I think that's about it.
Great. Okay, well, thanks a lot, John.
And, well, I guess my contact is there if anybody does have any direct questions or anything.
Yeah, actually, there were quite a few still. There were a few dozen questions, actually, and a lot of them from municipal participants, and I'm sure you'd be happy to follow.
Yeah.
Specifically about implementation of the program that they're also trying to implement. So thanks again, John. Your email address is there, so people can follow up if they'd like. And very informative, and hope we'll have you back at some point in the future for an update, maybe.
Sure.
Okay, thanks a lot. And with that, we'll end the webinar.